In this lab, we are observing and modeling an object in freefall. The two forces that will interact with the object are gravity and air resistance. For the procedure for this lab, we're supposed to take a video of an object in freefall starting from rest. The object should be one such that there will be some air resistance experienced in freefall. Once we have the video, we're supposed to plot a position versus time graph and tracker. After that, we're supposed to make a model for the object only using gravity as a force. And then we're supposed to make a third model that incorporates both gravity and drag force. And then we're supposed to compare these three plots. The physics principles incorporated in this lab are Newton's second law, which states that the net force is equal to the change in momentum over the change in time. The two forces interacting on the object will be gravity, which is a constant force, and the acceleration due to gravity is equal to negative 9.8 meters per second squared, and the drag force, which is not constant and is proportional to the velocity squared and is always in the opposite direction of motion. A model will incorporate both of these forces. Here's the video I took in Tracker. I used a crumpled up piece of paper from an object so that it would experience some air resistance, and the axis is flipped horizontally because that's the way my video was imported. So here's the video running. And here is the position versus time graph that was plotted. Here's the code I used for the model that only incorporates gravity. You can see here that the ball velocity is equal to the ball velocity times the net force divided by mass times delta t over a small delta t, and this process is repeated over and over. Here's the code I used for the model which incorporates air resistance. As you can see, there is still gravity there, but there is also the force of air resistance, which is the velocity of the ball squared times a constant b, and the sum of the forces is gravity plus the air resistance. Here are the three position versus time graphs plotted. The blue line is the observed motion, the green is the model with gravity only, and the red is with gravity and air resistance. As you can see, the gravity and air resistance model and the observed, the final position is similar, and the model with only gravity, the final position is different. However, when you look, you can see that the gravity only model seems to start off slower than the observed, as well as the model with gravity and air resistance. And I think this is due to the fact that I might have put some force downward on the piece of paper when I was recording the video. Because the drag force is proportional to the velocity squared, there becomes a velocity where the sum of the force is zero. This is called terminal velocity. No matter how fast you could throw the ball at the beginning downwards, the object would still go to terminal velocity. This concludes my lab.